Good afternoon, students. In the last class, we discussed about that oxo acids of phosphorus and its preparation, compounds of phosphorus, the physical properties, and the chemical properties. Today, I'm going to start with a new group, that is group 16 elements. Group 16 elements, nothing but they are called as oxygen family. Okay, what are the elements present in there? This one last one is the radioactive element. I won't consider that. This is oxygen, sulfur, selenium, tellurium, polonium. Okay, oxygen, sulfur, selenium, tellurium, polonium. So students, its general electronic configuration is NS2, NP4. General electronic configuration of this group is NS2, NP4. That means this will ends with helium, NS2, NP4. Sorry, helium, 2s2, 2p4. So this will ends with neon, 3s2, 3p4. This one is argon, 4s2, 4p4. This is krypton, 5s2, 5p4. Xenon, 6s2, 6p4. The last one is the radioactive element. So that is radon, 7s2, 7p4. Okay. Okay, listen. Students here, so these group elements are called as chalcogens. Chalco means it is oxide. They form a stable oxide. So most of the elements started from these elements are oxides. So oxide forming genuine synthesis. Oxide forming elements are called as what? Chalcogens. Okay, so this is what electronic configuration. If we consider periodic properties, if we consider periodic properties, and take here these periodic properties. What are the periodic properties are there? Atomic radius, ionization energy, next electronegativity, electron gain enthalpy, these are the periodic properties. So students here, atomic radius from oxygen to polonium. What is happening here? Listen, 2s, 3s, 4s, 5s, 6s means the number of shell goes on increases. That means atomic radius increases from oxygen to polonium. From oxygen to polonium. Next, of course, if the size increases, the energy, ionization energy, obviously decreases from oxygen to polonium. Similarly, electronegativity also decreases from oxygen to polonium. And next, electron gain enthalpy also decreases from oxygen to polonium. You know that students, if the size increases, then these properties decreases. If the size decreases, then these properties increases. So along the group, air size goes and increases. Size ಜಾಸ್ತಿ ಆಗ್ತದೆ. So that's why these are decreases. This is what periodic properties. Okay. So next one is physical properties. Okay. Physical properties. Okay. So what are the physical properties here? Okay, listen. So physical properties here are here if we consider these non-metals, these two are metallites. This one is a metal. Selenium is also a metal. Okay. So these two are non-metals. This one is a metallite, and this one is. These two are metals. Understand? This is the physical property. Of course, students, non-metals have less boiling point. This one has more boiling point. Metals has more boiling point. So along the group, the boiling point increases. Remember that. Understand? Only these three you remember. Oxygen and sulfur are non-metals. Selenium and tellurium are metallites. And polonium is a metal. That is the physical property. And boiling point is there. As we move from top to bottom, oxygen to polonium, boiling point increases because non-metals has less boiling point, metals has more boiling point. Okay, so here I write this physical property here only. These two are non-metals, these two are metallites, and this one is metal. So here I take students chemical properties, general chemical properties. Listen, in this property, reaction with hydrogen is there. Next, reaction with oxygen. Next, reaction with halides. Understand? Reaction with oxygen, hydrogen, reaction with oxygen again, and reaction with halides. So students, here, if we consider E as the 16 group elements like oxygen, sulfur, selenium, tellurium, polonium, here they form H2E type compound. Okay, when these 16 group elements E combined with H2, they form H2E type compounds. So here I write H2O, H2S, H2SE, H2P, H2PO. This is the type of compounds formed when the 16 group elements reacts with this. So students, in this one is a liquid. These two are solids. Actually, this is PeH2 and POH2. These are hydrates. They form hydrates. So this is the solid, this is gaseous in state. These are also solids, but they form hydrates. These two form hydrogen, means H2O. This is H plus instead. Here H plus instead. Here H plus instead. But here H minus instead. Thus, these two belongs to what? Metals. They exhibit a metallic property. Okay, you remember only this much? They form H2E type of compounds. H2O, H2S, H2AC, H2PE and H2PO. In that, hydrogen bond is more. Here, hydrogen bond is less. Okay, so along the group from oxygen to polonium, hydrogen bond decreases. Okay, so hydrogen bonding decreases from oxygen to polonium. Understand? This is the one thing you have to remember, the reaction of hydrogen. That is enough. Which type of compound they will form. Next, listen students. Reaction with O2. They form EO2 and EO3 type compound. EO2 and EO3. So in EO2, this E is sulfur, selenium, tellurium, polonium. Understand? And oxygen also. Oxygen, sulfur, selenium, tellurium, polonium. In which type? EO2 type. In EO3 type, it is only sulfur, selenium, tellurium, polonium, not oxygen. Remember, in EO2 type, E means oxygen, sulfur, selenium, tellurium, polonium, all. O2 means what? O3, nothing but ozone. Correct? O2 means ozone. This is SO2, this is SeO2, this is PeO2, this is PO2. Correct? This P2 type compounds. The students here, if you consider here O, this become O4, this cannot be exist. So here E must be equal to sulfur, selenium, tellurium, polonium, but not oxygen. So it is SO3, SeO3, PeO3, and PO3 type compounds. Understand? So students here, these oxides are in +4 as well as +6 oxidation state. Here they are in +4, here they are in +6 oxidation state. This is the chemical property. They form H2E type of compound when they react with hydrogen. They form EO2 and EO3 type of compound when they react with oxygen. Okay. Next, they form EX4 and EX6 type of compounds when they react EX2 as well as EX4 and EX6 type of compounds when they react with halogens. Okay, so students, in EH2, it may be oxygen to polonium, but here only sulfur to polonium. Here also sulfur to polonium. In these two, oxygen is not there. Why it is not there? Oxygen cannot exhibit +4 and +6 oxidation state. Why it cannot be exhibit? I'll explain later. Listen. So if we consider oxidation trends, so there are four types of oxidation states there. One is -2, one is +2, +2, -2, +4, +6. Okay, so students, -2 oxidation state decreases from oxygen to polonium. -2 oxidation state. Stability. Okay. Stability decreases from oxygen to polonium. So +4 oxidation state increases from oxygen. Increases from oxygen to polonium. +6 oxidation state also increases from oxygen to chlorine. What this states? So listen, oxygen is only stable in negative oxidation state. It cannot exhibit +4 and +6. But the remaining elements, that is sulfur, selenium, tellurium, polonium, they preferably exist in +4 and +6 oxidation state. They cannot attain -2 oxidation state. Even though they attain, okay, even though they exhibit -2, but they are unstable. So let it the -2 +4 +6 oxidation state. -2 oxygen ಮಾತ್ರ ಇರುತ್ತೆ. ಅದು +4 ಮತ್ತು +6 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಇದಲ್ಲ. ಯಾಕೆಂದ್ರೆ ನೋಡಿ ಕಾನ್ಫಿಗರೇಷನ್ ಅಲ್ಲಿ 2s2 ಇಲ್ಲಿ 3s 3p ಇದೆ. ಆಫ್ಟರ್ ದಟ್ 4 3d ಬರುತ್ತೆ. Here after 2s2p 3s is there. 3s 3p 3d is there. ಅಂದ್ರೆ d ಆರ್ಬಿಟಲ್ಸ್ ಇರುತ್ತೆ. ಇಲ್ಲೂ ಅಷ್ಟೇ 4s 4p 4d 5s 5p 5d 6s 6p 6d. ಅಂದ್ರೆ ಎಲ್ಲದರಲ್ಲೂ ನಮಗೆ d ಆರ್ಬಿಟಲ್ ಅವೈಲಬಿಲಿಟಿ ಇದೆ. Okay, so because of that, now we have electron excite ಮಾಡಿದ್ರೆ we have enough space for the exciting electron, that is availability of d orbital. But ಇಲ್ಲಿ oxygen ಅಲ್ಲಿ 2s 2p ಅಂದ್ರೆ 3s ಇದೆ, d orbital ಇಲ್ಲ. So that's why it only exhibit -2 oxygen. ಅದು ರೀಸನ್ ಯಾಕೆ +4 +6 ನ ಎಕ್ಸಿಬಿಟ್ ಮಾಡಲ್ಲ ಅಂದ್ರೆ ಇದರಲ್ಲಿ d orbital ಇರೋಲ್ಲ. Okay, so this is all about general trends, their electronic configuration, period, physical property, and also chemical property of group 16 element. So the next we discuss about anomalous behavior of oxygen. Anomalous behavior of oxygen. It is anomalous properties of oxygen. Okay, so for this anomalous, these are very important for humans. Okay, anomalous behavior, that is one, that is the smaller size. Next, second, high ionization energy. Okay. Next, electronegativity. And last, absence of d orbital. These are the anomalous reasons for anomalous behavior. Anomalous means different. Why it behaves different? Okay, so this is anomalous behavior. Smaller size, higher ionization energy, high electronegativity, and absence of d orbital. Okay. So next one is anomalous property. Due to these reasons, what are the properties, different properties exhibited by this oxygen? Whereas Other elements are polyatomic, whereas other elements are polyatomic. Means oxygen is like O2, sulfur is like S8. Oxygen is sulfur is S8. This is diatomic. These are polyatomic. Okay. Next one. Third one. Oxygen can form hydrogen bond, whereas other elements cannot. Whereas other elements cannot form hydrogen bond. Reason: due to the smaller size and high iodization. Due to the smaller size and high electronegativity, it forms hydrogen bond. Due to the large size and less electronegativity, the remaining elements cannot form hydrogen bond. Next, the fourth one property is oxygen covalency is 4, whereas others is 6. Maximum covalency is 2, whereas others is 4 and 6. Others are 4 and 6 like -2. Only 2 bonds it may be formed. That is +4 and +6 means 4 bonds and 6 bonds. That is called covalency. 4, 6. This one is to oxygen as the covalency only 2. It can form only 2 bonds. So next students, it shows different oxidation state. Negative oxidation state. That is -2, -1. Oxide and peroxide. Like -2, that means oxide. Another one is -1. That means peroxide. Whereas others show positive oxidation state. +4, +6. Whereas others shows positive oxidation state. That is +4 and +6. And the last one, students, H2O is liquid. H2S, H2SE are solids. These are the anomalous properties of oxygen with respect to other elements. You know, in the same proteins, each and every atom should possess the same type of property. Oxygen shows this type of different property because of these 4 reasons. Any 4 property and any 4 reasons is very important for both anomalous behavior as well as anomalous property. Understood? Listen, this anomalous behavior is same for everything. For nitrogen also it is same thing. Small size, high ionization energy, high electronegativity, and absence of DR. compounds of oxygen I take, directly I take differences like oxygen that is O2 and another one ozone that is O3. Only two compounds are there. In that I can say preparation, physical property, chemical property. Okay, take on this chart. This is very important. First is preparation. How this O2 is prepared. So students, first reaction is potassium chloride. This one. Potassium chloride decomposes in presence of MnO2. Upon heating, in presence of MnO2, decomposes. That means separates out, splits out into 2KCl plus 3O2. 3KCl plus 2O2. This is one type of preparation. Next, second type is from metals like Ag to O type 2 moles. Upon decomposition, they give 4Ag plus O2. 4Ag plus O2. Next, Pp3O4 type compounds gives 6Pb O2 plus 4O2. 6Pb plus 6PbO plus 4. This next one, that is PbO2 type compound. That is 2PbO also. That you get 2BbO plus 4. Other decomposition reaction upon heating, they decomposes. One reactant is there, two products are there, then it is decomposition. If two reactants, one product, that is combination. If two products, two reactants, two products, that is displacement. If two products, two reactants, three or more products, that is double displacement. That is the type of reactions you studied in the which chapter it is? Redox reaction first. Okay. The next one is that is Hg2 upon decomposition gives 2Hg plus O2. Okay. This is preparation methods. Students, next one is physical properties. I'll say this is colorless, odorless, tasteless. Yes. Okay. Next, partially soluble in water. So students, of course, oxygen is partially soluble in water. Because of that reason, aquatic animals survive in water. You know, underwater animals live like fish, frog, okay, and plants, aquatic plants also there. Okay, so those are requires oxygen. So that oxygen, that is biological oxygen demand, you know, the BOD. Okay, so that one is enough for aquatic animals. That is only 3 cm3 of the oxygen is dissolved in 100 cm3 of water. Remember, 3 cm3 of water is dissolved in 100 cm3 of water. 3 gram oxygen, that is enough for aquatic animals respiration. Okay, so it is partially soluble in water and its boiling point is -183 Kelvin and freezing point is, that is 218.4 degree Celsius. So this is Celsius. Understand? So students, this one has isotope, that is O17, O16 and O18. This oxygen has isotope O16, O17 and O18. But the abundant is O16. That's why we are considering O16 as the basic oxygen atom. Okay. So next one is chemical properties. So students, you know that oxygen is not a combustible gas. Means if oxygen is there, the fire cannot catch that oxygen. If hydrogen is there, fire it catches fire very easily. But in presence of oxygen, the combustion enhances. It encourages the combustion. Okay. So first one is oxygen increases or supports combustion, but it is a non-combustible gas. If alone oxygen is there, it won't catches fire. But if already fire is there, then if we supply oxygen, it increases the combustion. That is, O2 supports combustion. Okay, this is first point. Second, carbon is there, undergoes combustion, then it forms CO2. Okay, if glucose is there, that is C6H12O6. If oxygen is there, then it forms 6CO2 plus 6H2O. Here 5 moles of O2. Sorry, 6 moles of O2. That is combustion reaction. Okay, so students, if calcium is there, when it reacts with oxygen, it forms 2CaO. Moles we know. These are all the chemical reactions. Means when it reacts with metals, when it reacts with non-metals, when it reacts with hydrocarbons, they always forms this type of compounds, oxides. Listen, this is preparation, physical property and chemical property. So students, another one is there, they form oxides. Okay, I will write example here. So they form oxides. In that oxides types is there. One is acidic oxide, basic oxide, amphoteric oxide, and neutral oxide. Listen and write the example. What are these acidic oxide, basic oxide, amphoteric and neutral? Listen, I'll take an example of CO2, SO2, Cl2O7, N2O5, etc. One acidic oxides. Here I take the basic Na2O, BaO, CaO, etc. For this I take Al2O3. Okay, for this I take Al2O3, ZnO, BeO, etc. Okay, later I will explain what is this acidic, basic and amphoteric means, and thus for this neutral, that is CO, NO. Okay, CO, NO and so students, what is this acidic oxide means? When this compound CO2 reacts with water, they form H2CO3. Okay, listen. Then SO2 when reacts with water form H2SO4. SO2 and also SO3 you may take. Then you take SO3. form H2SO. Understand? So students here, I'll take this Na2. If it reacts with water, no doubt it forms 2NH, same aqueous. Okay? So then it will form Al OH 4 times is 2 plus Na3. This one is 6H2, 3H2O, this one is 6NH. Listen students, so this one is why it is called as acetic oxide means if these oxides reacts with water. Water means water is amphoteric. When it reacts with acid, it reacts. When it reacts with acid, it behaves like base. When it reacts with base, it behaves like acid. Amphoteric nature. It can show the property acid as well as base. So here CO2 reacting with H2O means forming H2CO2 and H2SO4. These two are acids. Okay. So upon ionization or hydrolysis, these gives acids. That's why they are called as acidic oxides. Here they are giving me base. NaOH is also base. BaOH twice is also base. So that's why these are called as basic oxides. Here it can react with acid as well as base. That's why it is a base itself, amphoteric oxide. And why this is neutral means they cannot react with any reactants. They are unaffected. That's why these are called as neutral oxides. They won't possess any acidic character as well as basic character. This is the types of oxides of metals and non-metals. So students remember, if the oxides of non-metal, carbon is also non-metal, sulfur is also non-metal. If oxides of non-metals are there, they are called as acidic oxides. If oxides of metal, sodium is also metal, this one is also metal. That is called as basic oxides. This one is what? Metalloid. In between that. Of course, aluminium is metal, but it is a p block element. It is in between S and extreme p block means this shows a partial character, as well as acidic as well as basic. Okay, that's why this is amphoteric in nature, and these are neutral. Neutral means they won't react with any acid as well as base. So this is all about oxides. So students, why I am writing these in the same book means, without explanation, why I am writing only these equations? Because they always used to ask complete the reaction quickly. Again and again I am repeating the same word. They always used to ask what? Complete the reaction. They only give this time, this reactions, this condition, you have to write this. Always. Understand? That's why I am writing only these reactions. You just practice these reactions, then you will get completely 6 scores. Okay? Thank you.